Okay, this is Nick from Electric Worlds Australia, aka Perth Electric Scooter Repairs. This is just a quick video on how to check your Segway Max G30 series scooter for controller failure. This is, as you can see, is the Max G30 P. The LP doesn't have the converter from 240 volts down to the various voltages required to run the scooter, because you've got the power pack, okay, that you plug in there. But generally speaking, and there's a new one updated in the theory behind this repair or testing is identical. So what I've done is I've disconnected the battery. So the battery, I've disconnected the battery from the controller via the XT connector. So that's the battery side of the XT60 connector, and this is the controller side of the XT connector, which goes into here. Now, as you can see here, I've disconnected the battery from the circuit, and it's flashing blue, which means that the battery is saying that it's fine. If you've disconnected it and it's nothing showing or is red, which it would be red if you had all these black connectors, I'll show you, all these black connectors melted, okay? You just cut it off like I did. And what you do is you make sure that the 3 wires going to the motor are cut and separated. Make sure you've got some clean insulation on it, all right? Now, the other thing too is that the copper wire also may show a bit of a tinge from burn. If you've got that, then you'll need to cut a little bit more off. We're only talking about, a couple of mils each time. And the same goes for this. You just snip it off. Although the silicone, generally speaking, can handle the heat, no problem. It's just that these plastic insulated wires tend to melt quite considerably. So I have snipped off those 3 connectors. But what I would have done first is disconnected the battery from the controller and basically from the whole circuit, all right? You don't have it plugged into anything. Now, I've got a multimeter here on ohms, okay? And if you see here, that little icon there, that is a diode. And the purpose of a diode in a circuit is to allow current to flow in one direction but not the other. This is something that is vital in a lot of electronics. So the aim here is to connect it up, because the multimeter will put a voltage across the red and the black connections, all right, and the leads. So there's a voltage across it, so it produces that to be able to try and see what voltage is across the these 3 wires here. Now, these 3 wires, you can, if you want to remove this controller by there's, I think they're 4 or 5 mil hex head bolts down the side there. You can remove it out if you want to make it easier to get to, but you don't have to, okay? And then what you do is the controller's XT60 negative wire, okay, you see the black, you connect up the multimeter's black lead, which goes to the common, and then with the red one, where's the red one? Here it is. You connect up to the 3 wires coming out of the controller that would invariably go to the connectors and then off to the motor. Now, these are high power or high current wires, or the high current goes through it, which is battery voltage. So I'm just putting it onto the blue, and as you can see here, if I do it right, okay, single-handed, all right, climbs up and then goes open load, well, overload I should say. It's and the same here, okay, to the brown. Hang on a sec, it's going to look messy on the screen. There you go, and it does the same, okay, and then the same for the yellow one. So excuse me as I drop the multimeter onto the yellow one. Okay, and that does the same thing. Okay, that's great. Now what we're going to do is we're going to put the black lead onto the red wire. Okay, this time on the controller. All right, sorry about them. It's all over the place, but I'm trying to do it one-handed and I don't have a lovely assistant to help me. Oh, there we go. Sorry about that. I could edit it, but you know, I just don't have time for that kind of caper. Anyway, so I've connected up the positive to the common this time, and now I'm going to do the blue wire. And it's coming up with 0 volts. Okay, if I do it to the yellow, okay, won't be a sec. I just stabbed myself. It's showing 0.495 or 0.5 of a volt. And then the brown one, the final one, is showing 0.5 again. So the blue one, okay, when I connect it up, I should be getting 0.5 as well, 0.5 volts. But when I connect it up, it's showing 0. So we have a problem with the MOSFETs associated with that blue wire, okay? Therefore, this controller has failed. You can actually determine that quite easily. When these are all melted together, the rear wheel will not turn. If you spin it, it won't turn more than about half a turn. All right, there's a lot of force going against what you're doing. If this is all fine, or you've snipped it like I've done here, and you spin it, that motor should spin freely about 2 or 3 times. Okay. If you snipped it and you have made sure that these wires are separated out from each other, okay, they're not touching each other, and you still have a problem, there's a possibility that there's a problem with the motor itself. Now, I have come across an issue with when these melt, or the connectors melt, so that when these connectors melt, they also so close to the other cable, or these other 5 little wires that come from the motor, okay, and as you see, it's been a little bit, well, so blackened, but bit burnt. Those 5 little wires are 5 volts. They run on 5 volts from the controller, whilst these big ones are running at the battery's voltage. In this case, it's 36 volts. Now, when these all melt, okay, and they heat up, and sometimes they join up, etc., is because the insulation is melted and the 2 wires touching inside. They also have in the past twice for me, or for a customer, where they've heated up, melted through the black bit, melted through those wires, insulation, coloured insulation, and the 36 volts has touched the 5 volts. Okay, when that happens, there are inside, hang on, I can actually show you on this one. Those 3 wires go to these little components here, those little black things. They're Hall sensors. They're like little transistors, but they're Hall sensors. They detect magnetic change, so that when the magnets, which you don't see here, where are the magnets? Hang on a second. All right, so there's the magnets inside, permanent magnets, okay? And then you've got your coils. All right, if you've been watching my videos on my page, you'll know what I'm talking about here. Now, these aren't magnetic, but the coils generate, when they get the 36 volts, they generate a magnetic field and interact with the permanent magnets, causing the motor to turn. Now, what can happen when the 36 volts touches the 5 volt lines, it destroys these little components here. Okay, and that basically means either you've got the ability, or someone's got the ability to replace those Hall sensors, okay, which I think I've got some spares floating around. I can just interchange them. This one doesn't have that problem, luckily. As you can see, it hasn't melted through. But these motors are repairable, but it does take a few hours to do this work. It's not something simple. So if you think it's a quick change and it's only $50 to fix it, for a technician, then, you know, in many ways it's cheaper to buy a new one than fix it. And what I do is, when I actually trade in the old motor for $50. So you get a discount. And then in my own time, in my own OCD way, I hate seeing motors going to waste and being thrown out. Anyway, so back to this. So we know for a fact that this one showed 0 voltage between the positive, okay, wire of the controller. Okay, that's not it there. Ignore that. All right. But it does go inside. That one does go inside down here between the positive and the outputs of these wires. So this one has failed. So then needs replacing. And yes, any of the any connector that's got a 60 on it, like the I think the XT60 or MG60 that others have mentioned, with the 3 connectors, all right, and do the same. Now, one thing, what happens if you have got bullet connectors? Bullet connectors will do the trick as well. I've replaced them with bullet connectors, and I'll show you which ones I'm using. Now, again, as I said, I've shown this in a previous video, but I'll show it again. Won't be a sec. Okay, so I've got here, I tell you, it costs a lot of money to collect these after a while, but it's the way it goes. So in here you've got the AMASS branded connectors. There are cheapy ones that can't handle the temperature of the soldering, so make sure that they are AMASS connectors. They tend to be more tolerant of heat when you're using your soldering iron. So these ones here are XT90, they're huge. Okay, they're more for the e-bikes type of connectivity. You wouldn't use those. Then you've got the XT60. So the XT60 is a little bit smaller. Okay, little, but they can handle the current on practically every single scooter on the market. All right, electric scooter. I'm not talking about e-bikes or anything like that, but they'll probably work as well. I recommend either these ones, okay, they're 60 series as well, or these are 30 series. They're too small, but you can get, here we go, you can get 90 and 60 series on those, and that is good for compactness, and they'll work quite nicely. Actually, I don't even know what these are. Yeah, they're 90s what I've got. I've got to find my 60s. If I haven't got any, I'll get some. So anyway, I mean, it doesn't mean you can't use the 90s. You can use the 90s. Don't use any of these silly type of connectors or anything like that. You know what I mean? Now, going back to bullet connectors. Now, if you notice the wire, well, you probably wouldn't have noticed, but I know that the wire inside here is thicker than the wires on here. So you actually have to be careful in what bullet connectors you use. So we've got standard 4mm connectors here. I think these N ones are 5, okay? But the 2 blues and the 2 reds are 4mm. But they're different in the sense that at the back of them, all right, at the back of them, the hole is slightly larger on the blue ones than on the red ones. And what I do is, the slightly larger ones, and your electronic store should know which is which, but I got these locally in Australia. This is through, what are the electronic shops? Alltronics or J-Car, that's it. All right, so the larger hold blue ones I use on the controller connectors, and the skinnier or smaller hold ones on these wires. Now, the other thing to be aware of when you do this, you always, wherever the power is coming from, you always have the female. The male is always on the load, in this case a motor, or whatever else that you're doing in electronic or electrical world. You should be connecting up, because the last thing you want, if that disconnects some reason and touches the some other part of the circuitry and it's pulsing 36 volts, you can cause further damage, even to the controller itself. So you must have that as a female, the female end, as you can see here, female, and there's your female, and then you've got your male. Do not use these fellas whatsoever, or these, or anything else. Just use the ones that I mentioned here. So yeah, that's what I do anyway. But you notice also, like this connector here, it's got a bit of charcoal on it. That's okay. That's not a drama as long as she's still working. You can just, if you want to, break that off. But my suggestion is that a bit of heat shrink over it, okay, would be advisable if it seems a little bit sus. I don't think it's necessary to replace this, but if you want to, again, an XT60, not an XT60 in this case, but certainly XT60 would be an option in the connectors. And of course the XT60s are just the 2-pin, all right? But again, same applies here. The supply gets the female and the load gets the male. Okay, boys, remember that. So that's about it. That's my lesson for today on this. But before I go, just a bit more, of course, as it always is with my videos, something else I think of, is that because you've got your power ports here, this is how it is on the Max G30P series. You've got your high voltage going in here, and then you can have a charger going in, your brick power source. Just make sure that those wires aren't damaged as well. Okay, you've got a connector there, all right, and make sure that, see, it's got a little bit of damage there, but that one's fine. I've checked that. Okay, it's not bare, it's just a little bit melted. In theory, what I normally do is, which I've done in the past, I just put a bit of heat shrink on there, just to be doubly safe, because electronics can trick you in that regards. But just make sure your wires are fine. Okay, that's about it. That's all I can tell you for now. One day I'll use a GoPro to go through the whole process and put it on my YouTube channel. But right now, this is all I'm going to give you. All right, take care. Bye for now.